Okay, here's example 5 with intersections. So this example is actually going to involve intersections and unions. So make sure that you're familiar with both of those before we move on with this example here. So we covered both intersections and unions in separate videos earlier. So what we want to do now is illustrate this fifth property here. When we talked about intersections a couple videos ago, we talked about the definition, some properties, and some simple examples. So here we're going to illustrate the fifth property. So we have three sets A, B, and C. So what we're going to do is first see what this is here, and then we're going to see what this is and show that they're both the same. Okay, so A intersect B union C, what we want to show basically is that this intersection distributes over the union. Okay, so let's figure out what this guy is first. So A intersect B union C, like that is what we're going to do first. Okay, so A intersect B union C. Okay, and again, remember, do what's in the parentheses first. Okay, so what we have to do is B union C first, so let's see what that is. So remember unions, remember a union is everything that's in B or C or both, right? So what's in B? 2, 4, 6, 8, 10. What's in C? 5, 6, 7, 8, 9. Okay, so did we write 5 yet? No, so we have to write it. Did we write 6 yet? Yes, so do not write it again. Remember, only write it once. Okay, so we already wrote the 6. So even though 6 is in both B and C, it appears twice, we only write it once. Okay, remember for the unions, only just write stuff once. Okay, so don't write the 6 because it's already there. 7 is not there, so we have to write it. The 8 already is there, so do not write it again. You have to write it only once. If it appears more than once, you still have to write it just once. And 9 is in C, but we haven't written it yet, so we'll go ahead and write it there. Okay, so this is B union C. Now we want to take this guy and intersect it with A. Okay, so now when we do A intersect B union C, okay, well, hey, if we want to, let's go ahead and call this set D. Okay, we're going to call this set D. So why are we going to do that? Because now we can just say, well, hey, what's A intersect D? Okay. Now, do we have to do that? No, but it's a little simpler to look at. Okay, this is just a little easier to look at than this right here, right? This is kind of a mess, intersection union, just kind of messy, kind of bad on the eyes. But this is a little easier to look at. Okay, but do we have to do that? No, we absolutely don't have to. If you don't like that, you can just forget about this, erase that, get rid of that D there, and just intersect these two guys directly. But no matter how you think of it, A intersect D, so that's everything that's in A and this set here. Okay, so what's in A? 3, 6, 7, 8. Do these guys, any of these guys also appear in this set? 3 does not appear here, so 3 is not part of the intersection, because remember, to be in the intersection of two sets, you have to appear in both sets. Okay. 6 appears in A. Does it also appear here? Yeah, there's 6, right? So we know we have a 6 at least. Do we have anything else? 7 appears in A. Does it appear here? Yes. Okay. So we have a 7. Do we have anything else? 8 appears in A. Does it appear here? Yeah, there it is. So our answer is 6, 7, 8. Okay. So A intersect B union C like this is 6, 7, 8. Okay, and again, we talked about in the previous video, even though we're intersecting these two sets here, A and D, it's enough to just go through one of them completely. Okay, why is that? So we're intersecting this set with this set, so it's enough to just go through this set, because if we go through this set again, we're going to say, well, hey, is 2 in A? Well, no, it's not, and if it were, we would have found it when we went through A. Okay, so there's no point in going through this one. Okay, because if this has something in common with this, we would have found it when we were going through this set. Okay, so it's enough to just go through this one. Okay, so that's doing it like this. So that's A intersect B union C like this. Now let's do it like this. Okay. A intersect B union A intersect C. Let's go ahead and do it like that. So a little more going on there, kind of, sort of. So we'll erase this. So now what we want to do is A intersect B union A intersect C. Okay. So remember, always do what's in the parentheses first. So we actually have two separate things in parentheses, so we'll look at one at a time. So what is A intersect B? Okay, what is A intersect B? A intersect B, that's everything in A and B. What's in A and B? Well, what's in A? 3, 6, 7, 8. Anything here also appear in B. 3 is in A, does not appear in B. 6 is in A, does appear in B. Okay? does appear in B. 7 is in A, does not appear in B. 8 is in A and does appear in B. Okay, so the only thing that A and B have in common is 6 and 8, right? So the intersection of A and B is the set containing 6 and 8. Okay, 6 and 8. Okay. 6 and 8, because again, 6 and 8, those are the only two numbers that appear in both A and B, okay, 6 and 8. Okay, and again, when we do an intersection, we only have to look through one set completely, because if A and B have anything in common, you know, if we look through B, if we're looking for stuff that B has in common with A, we would have found it already when we went through A, okay? So that's A intersect B. Now we have to do A intersect C, and then take the union of those results. So this is A intersect C now. What's A intersect C? Okay. 3, 6, 7, 8. Do any of these also appear in C? 3 appears in A, does not appear in C. 6 appears in A, does appear in C. Okay, so 6. 7 appears in A, also appears in C. Great. So since it appears in both, it is part of the intersection, okay, just by definition of the intersection. So 7. What about 8, the last one to look at? 8 is in A, it's also in C, okay? So we're good, it's in both, it's in the intersection. Okay. And again, that's it, we don't have to look through C, because if we look through C for stuff that A also has, then we would have found it already when we went through A, okay? But we already found everything here. Okay, so A intersect, now we have to take the union of these two sets, okay? So we do A intersection B union A intersection C. Okay, so let me call this guy D. If we want to call it D, we can call this guy E. So now we have to do A intersect B union A intersect C. Well, hey, I'm calling this guy D now, and I'm calling this guy E now. So this is really just the same thing as D union E. Okay. Again, do I have to do that? No, I don't have to do that. So this, it looks like the word do, but this is not the letter U. Remember, union symbol is not the letter U. So that came out unfortunately. But anyway, do I have to do it like this? No, I don't have to do that, but I just think that this is easier to look at than this mess here, right? This is kind of messy, lots of stuff going on here. But we know what this set is, we know the elements here, so let's just call it something simpler. We'll call it D. Or if, you know, we already used D from earlier in the problem, so if you want to use a different letter, that's fine, probably better that way. But anyway, A intersects C, let's call that E. Okay, we'll call that E, because we know what this is, let's call it something simpler. Okay, so then we just have to do this. So what's everything that's in D or E or both? Okay, so we're doing the union, that's the union symbol, we're doing the union of D and E. Okay, so what's in this set and this set, or you know, what's in both of them or what's in either one of them? So what's in D? 6 and 8. That's it. What's in E? 6, 7, and 8. Well, we already wrote down 6, so do not write it again. What about 7? We haven't written that one yet. What about 8? Yeah, we already wrote that, so don't write it again. Just remember, for the union, you write down everything that's in either set or both sets, but you only write them down once, okay? So that's why we wrote down all of D first, and then we wrote down everything in E that we haven't written down yet, okay? So remember, we wrote down all of D, so 6 and 8, and then we went through E. 6, we already wrote it down. 7, we don't have it yet. 8, we already wrote it down. That's it, okay? So then our answer for this is 6, 8, 7, right? 6, 8, 7. Okay. So this, we just found this, right? D union E. Remember, we call this D, we call this E, so we just did A intersect B union A intersect C. Okay, we just did that. A intersect B union A intersect C. We just did that, and we got 6, 8, 7. And that is exactly the same as this, right? So remember, it does not matter what order you list these guys in. Okay, so the point is they have the exact same elements, 6, 7, 8, 6, 7, 8. Okay, it does not matter what order we list them in. Okay, so that's just an example of property 5 in action here. So if you want to do something like this, you could do it like this exactly, or you could distribute, so to speak, distribute the intersection over the union. Okay, so informally, that's kind of how we talk about it. But anyway, that's an example of property 5 in action, and that's example 5 with intersections, and this also used unions as well. So that's our example 5 here with intersections. Okay. So more stuff coming up in the next few videos.